Oh, yeah, okay. So, I'm hoping, I know that like last night, 32 and 33 were tough. Um, I already know that. 32 was quad formula with I, and there's foreshadowing that there's I in our chapter. So I want to do a little bit with I's here, just to kind of remind us what happens with I's. And these problems are not quad formula problems, clearly. But you guys know when you get a negative under the square root, you make an I in the front, right? Okay. Okay, so this is a box problem. So I'm multiplying two things together. And this is a binomial times a binomial, so I make a 2 by 2 box. I'm going to put 4 minus 8i in the top, negative 2 plus 2i in the side. 4 times negative 2 is negative 8. Negative 2 times negative 8i is positive 16i. Positive 2i times 4 is 8i. And positive 2i times negative 8i is negative 16i squared. Okay. Then I'm going to combine like terms. Negative 8 plus 24i minus 16i squared. Okay, now if this problem had any other letter in it than I would be done. So if those were X's or P's or smiley faces or anything else, the problem would be over. But I has a special property, if you remember. I squared is negative 1. So I substitute negative 1 in for I squared. I make that plus. And some of you guys could skip directly from here to here. And then actually this is going to be confusing if I don't combine those two. Just positive 8 plus 24i is your final answer. Okay, now find warm-up number 15. And this is kind of what some stuff you know already. And I need to do this problem to make stuff on the worksheet make more sense. So find all zeros. What are two other words that you can use instead of zeros? So it already has factors, roots and solutions. Okay, when you're finding all zeros, you take y, and everybody in the class should know f of x and y are the same thing. You take the y and equal it to 0. And this is what you did in the first problem of the homework with that quad formula. But this one's all factored for you, which is great. Okay, so then set them equal to 0 separately. Okay, so that one's easy. X is negative 1/2. Okay, now, big question. What do I have to remember every time I square root both sides of an equation? Nice. Okay, I'm going to pause here real quick and just help make a connection for you, I hope. What is the degree of this polynomial? 4. 3. 3. Because there's one x in the first parentheses and 2 x's in the second parentheses. So 1, 2, 3. Degree 3. Okay. Degree 3. How many roots, solutions, or zeros should it have? 3. And that is hopefully going to help you remember the plus or minus, because you get to the end and you're like, oh, it's degree 3. I should have 3 answers. But if you forgot your plus and minus, we would have only had 2 answers. Just trying to help. Okay. All right, so now I want you guys to flip to the worksheet, which is tonight's homework and the rest of the classwork after your puzzle. Okay. Take a look at the first 4. Do you know what to do for these? This is exactly like number 31 from yesterday, the thing that we did at the very end of the period yesterday. Let me show you. So if you're confused, you could look at 31 where we said the degree, and then we found the roots, which are the opposite signs, and then we figured out if A was positive or negative, and that helped us sketch it in. Does that make sense? Okay. The thing is, that reason I'm saying that is because remember how I said, I don't care how tall your like bounces are, your loops. Well, the answer key actually got the real graphs off of Desmos. Yours don't need to look exactly like this. They need to have the same number of bounces and the same number of squiggles, but like this guy, you would probably not know that this guy was shorter than this guy. You would not know that how far up this went. You would not know that this guy is shorter than this guy. You know what I'm saying? So like yours should look kind of like those, but they're not going to be exactly the same. Okay. However, I have a feeling from people's questions on number 33 from last night that you have no idea how to do the bottom section. So let's do that together. Okay. This is, and what number 33 was from your last night's homework. You remember how I said I did that fancy thing off of Desmos where I had these off the graph and went backwards to this? That's what these are doing. So it's saying you've got these. Now what is the equation? Okay. So this is very confusing. It's saying least degree here because just what I said yesterday, like some of them are weird, so you don't really know if you don't have the equation itself. Anyway, so okay. Oh, why is it blue? Oh, I'm gonna have to switch to blue then. You know, real problems here. Okay, so you're gonna start with y equals. These are easy, by the way. If it takes you longer than say 10 seconds to do any of these problems, you're doing it wrong. Okay, y equals. Okay, so this guy, this one is 0, right? And so that means that there's going to be a plain x in the front. And you could put x minus 0 in parentheses if you want. I'm totally fine with that. I will not mark it wrong. I just like the way it looks when the x is in the front. Okay, and then I go to this guy. So that's x plus 1, x minus 2, x plus 3. Done. So it's taking the answers and going backward to the equation. Okay, now we need to do 7 and 9 because there's weird circumstances in both of those. Okay, hold on. Y equal, this one does have a 0, right? Okay, what does this business mean? It means that the root is 2 with a multiplicity of 3, which means it's a triple. So this is the number inside, and this is how many times that occurs. So 2 multiplicity of 3 means it's 2 3 times, occurring 3 times. Okay, now these guys, and these guys, the fractions in this one are the whole reason that I did number 15 as a warm-up. So we're going to start by putting y equals, and Sean said there's no 0 in this one. So that means I'm just going to take my first one and make that x plus 3. It just means that I won't have an x in the front. That's okay. And then this one is x minus 3/5. And this one is x plus 3/2. Okay, and no equations are going to look like that. So we have to figure out how to make the factors not have fractions in them. And what I want to do is remind you, so go back to number 15, the warm-up number 15. And look at this factor. What did the answer end up being? A fraction. Okay, so this factor ended up being this fraction. Okay, so what you do is you say, okay, I don't want it to look like this. This looks terrible. So I have x equals 3/5. Don't do this math, by the way. Don't do this. Don't do this. You can, but don't do it. X minus 3/5 equals 0. That's what I'm saying right here. And then multiply everything by 5. Okay. And because we're smart people, we can get the pattern. So after I write the fractions, you can just multiply that factor by the denominator. Or you can just think about taking that and putting that in front, taking that and putting that in front. And why is that okay? Because you're going to set it equal to 0 and divide by it in the end anyway. Mrs. Summit, are you aware that you're missing a end paren? Did anyone notice my lack of end paren? Okay. Okay, so when you have fractions, write it as a fraction first, and then move the denominator in the front. It's like you're multiplying by that number to get rid of the fraction part. Okay, do you guys think you can do 6, 8, and 10 now? Okay, all right, take a look at the back. We're going to also do number 11. The rest of this stuff is review and whatnot. Okay, sketch the general shape of each function. State the degree and describe the end behavior. Your answers should not have axes, even though they are on the answer key. Okay, these problems, again, if it takes you longer than 20 seconds to do the problem, you're doing it wrong. These were not meant to be, you're like, oh my gosh, it's not factored. How do I figure it out? Okay, that's not what we're asking. Okay, so I wanted to go through this with you. It's really going to bug me that the 11 is not circled though. Okay, first question is, what's the degree? So how many directions should it have in its sketch? 5. Okay, and is A positive or negative? Positive, and just you want to put a 1 in the front if that helps your brain. Okay, now yesterday's notes, we said that if you have an odd degree, that positive A kind of acts like a positive slope, and it's kind of going uphill over time, which means that I need to start low and end high. So I'm gonna go 1, 2, 3, 4, 5. Do I care how big your bumps are? No. What do I care about? The fact that it's got 5 directions, 1, 2, 3, 4, 5, and then it's starting low and ending high. If you look at the answer key, it's going to be the actual graph of this, which I'm not asking you to do. I'm just asking you to sketch the shape. Okay, now we need to do the end behavior. You guys are really used to just filling in the blank. This is the bit that's always there for you so that you can just fill in the blank, but they don't have that on this one. So we had to actually write it this time. Travesty. Mrs. Talbot, how could you make us write it? It'll be filled in the blank. And I'm always going to have the left on the top and the right on the bottom. I'm not a jerk, I promise. Okay, so anyway, left arrow is going down, right arrow is going up. Left arrow is going down, right arrow is going up. So do you guys see the expectations here? So I just want the right amount of directions and kind of how the arrows go based off the degree and the A value. Really quick, if you scroll down to 17 and 18, just a reminder. That's the formula for area of a non-right triangle. 1/2 side times the side. And when I say side times the side, you realize it's not the same one, right? It's one side, side 1 times side 2 times sine of the angle between them. Remember that from December? It's been a hot minute. Those problems, if it takes you any longer than 10 seconds, you're doing something else. Just type in the calculator. Okay. All right. So now I'm going to bring you a puzzle, each group a puzzle. I need you to take everything off of your desk. Just set it down on the floor. You don't have to put it all away. Just even a pencil. You don't, nothing. These are laminated pieces that we're just going to put in the middle of your table. Yeah, open it up, spread out the pieces. I'm gonna help you start it. I need you to find me the piece that's a triangle. What? Live. I'll give one second. Thought I had nine. Okay. Okay, this puzzle makes a 3x3 grid. Do you know what I mean by that? Like 3 pieces, 3 pieces, 3 pieces. And the triangle's the middle piece. That's your big hint. Okay, so I'm gonna help you start. So you want to start based off of the triangle. What? This is facing up, I believe. I see. Okay, so what you're supposed to do is look through the other puzzle pieces and find the equation for this. Okay, so let's take a look at this one, guys. Shh. This one right here is a degree 4. It has a bounce at -3 and a bounce at 2. Do you guys know what bounces mean on the equation? Squared. Okay, so find me a squared at -3 and a squared at 2 in your puzzle pieces. Okay, and remember, you have to switch the sign. Sorry. Squared at -3, squared at 2. Oh, I found it. It's the okay. It's squared at -3, squared at 2. And there are a lot of them that look like this, but they had like X's in the front. This one does not go through 0, so okay. You guys with me? Squared at -3, squared at 2. Okay, so what you do is you line up that graph with its equation. And so that piece is done. If I were you, I would work off of the 4 sides of the triangle and then figure out the corners after. Does that make sense? Right next to the graph. So this equation matches this graph and those two touch each other.